Hi, everyone. It's been a while since I posted my last Golf Biomechanics episode. Today, I'm going to talk about golf swing events and phases. Golf swing events means an important instance in the golf swing. And once we identify the important instance, then we'll be able to also define the phases based on the events. Before we start the swing events and phases, let me direct your attention to the Golf Biomechanics playlist available on my YouTube channel. Currently, I have 4 episodes included in this playlist. So it's a torque part 1, 2, and 3. And also ground direction force. So if you're interested in, please go over these first and then watch today's episode. I plan to post more Golf Biomechanics episodes from now on, and it is important to understand the swing events and phases that I use. But that's why before I start talking about Golf Biomechanics. And I'm introducing the swing events and phases first again. Okay, this slide is from the torque part 3. So what we see here is the torque generated during the golf swing. At this particular instant here, we have the GRF torque in the front plane, and then the vertical torque acting about the vertical axis. When you combine these, then this will be the combined torque. This basically defines the swing axis. But the purpose of this slide is not to explain these, but rather I try to direct your attention to these here. So basically, in this graph, we have time axis here, and then different torques generated during the swing. But on the right here, you will see these numbers and then also these abbreviations or acronyms, BA, MB, LBA, LB, and so on to MF. These are actually the swing events, important swing events. So I have all these numbers marked here. And so today, I will explain what these are all about, and then also some additional important events. So let's take a look at the swing events. So first, the set of events here, we have BA, MB, LBA, and LB. BA stands for breakaway. I think I originally started using the term ball address, but then eventually changed it to a breakaway because I tried to emphasize the importance of breaking away from the static posture. So in a dynamic swing motion, then you have to break away from the static setup position well. So in order to emphasize the importance of this breakaway, I changed it to a breakaway. So in other words, this is the address position, but this is the beginning of the backswing motion. So this is when the club head starts moving. And then the second event is mid backswing. So M stands for mid, and then B stands for backswing here, mid backswing. So whenever from now on, when I say mid something, then that means that the shaft is parallel to the ground. So this is the instance when the shaft becomes parallel to the ground during the backswing. So that's why it's called mid backswing. And then there are 2 late backswing events here. So simple late backswing, which is based on the club position in the frontal view. And then this LBA is based on the arm position. So particularly the lead arm here. So this is the instant when the lead arm becomes parallel to the ground. So still both late backswings, but initially I used this event in the analysis, but later I found out that in teaching, golf teaching, this event is used quite often. So I inserted this. And instead of inventing a new name here, I just added a arm-based. And these are also called the P1 position, P2, and P3. If you're familiar with the P system, this is P1, P2, and P3. Now, this doesn't have any P number here. And also, between the late backswing arm-based and the late backswing, this is the typical sequence. So you'll reach LBA first and then LB. But in some cases, these two can be switched. So those who will start the backswing with the early wrist cut, then you'll have the club aligned vertically first, and then the left arm or the lead arm becomes parallel to the ground. So these two events can be switched. And this late backswing does not have any P number here. Then the next set of events here, we have the first one is the EPR. This stands for end of pelvis rotation. So in other words, this is the pelvis transition point. So pelvis turns backward and then stops at this point and then starts rotating in the opposite direction. So it's called the end of pelvis rotation. Top of backswing is the club transition point. So when the club changes the direction of rotation in the front of you. And then EDA and the ED, both are early downswing phases, early downswing events. But again, when the lead arm is parallel to the ground, then it is called the early downswing arm-based. And then when the club is vertical, then it's just the early downswing. And in the downswing, you always have early downswing arm-based first, and then early downswing. So these two cannot be switched. These can be quite close to each other. If you have a casting-like early casting action, then these two can be quite close to each other, but it will be almost impossible to switch these two events. And then TB, top of backswing, is a P4, and then EDA is a P5 position. And then between end of pelvis rotation and the top of backswing, we can define some additional events based on the transition point. So ETR is the end of thorax rotation. ESR is the end of shoulder rotation. EAR is the end of arm rotation. So between EPR and TB, this phase is defined as the transition phase in my case. I define this time interval as the transition phase. So typically, pelvis is the first one transitioning from backswing to downswing. And then club is the last one. And then between these two, we have the thorax changing the direction of rotation, and then the shoulder girdles or the shoulder line. And then this is the, this is based on the so-called upper lever. But roughly, we can say that this is the end of arm rotation. So you have a sequential transition from the pelvis to the thorax, and then shoulder, and then arms, and then the club. So we can certainly add these events. And then between top of backswing and the EDA, we can also add some additional events. The first one is maximum unweighting. Unweighting means if you look at the ground rotation force episode, then you'll be able to see the meaning of unweighting. But unweighting means that the vertical ground rotation force is less than the body weight. So when you have the maximum unweighting, this usually occurs between the TB and EB. When you have really active backswing, then this will occur right after top of backswing. If your backswing is really peaceful and you don't prepare your body that well during the backswing, then this will attempt to occur somewhere in the middle of this phase here. And also, the next one is the MC maximum cocking. So maximum cocking means that when the wrist shows the most cocking, or this will be the beginning of the uncocking phase. So it can be called as a maximum cocking or beginning of the uncocking phase. Or this is the point of release. So the uncocking will start at this point. When the maximum cocking occurs near top of backswing, it's called the early release. And when the maximum cocking occurs close to EDA, then it's called the delayed release or late release. So depending on the timing of the maximum cocking or timing of the beginning of the uncocking, you will see different cleavage speed at impact. And after early downswing, When the early downswing is when the club is aligned vertically here in the frontal view. But slight after early downswing, we typically have the maximum GRF, maximum ground reaction force. So the ground reaction force is, at this position mainly coming from the lead foot, but the total ground reaction force becomes the maximum at this point here, which is slightly after early downswing. So we can again add a lot more events than these P points. Then the last set of events here, MD is the mid downswing when the shaft is parallel to the ground, and then ball impact. BI is ball impact, and mid follows through. That means the club is again parallel to the ground during the follow through phase, and then late follow through when the club is aligned vertically again. And that these coincide with the P6, P7, P8, and P9 positions. We can also add additional events here. So between the EDA and the mid downswing here, MD, you will have the maximum hand velocity instant. So at this instant, the hand velocity becomes the maximum. And then slight after impact, we have a zero cocking. So when the wrist loses cocking completely. So here, this line is called the upper lever. Later, in the next episode, I will talk about the inclined axle chain system. But this is called the upper lever, and then this is the lower lever. And when these two align, then that's the zero cocking event. So the wrist actually loses the cocking, wrist cock completely. So this way we can add a lot more events to the typical P positions. But that's why the P system is not good enough in terms of analyzing the swing motion. In the instructions, you can use the P system to roughly mean certain positions. But when we have in-depth analysis of the swing motion, then the P system is not enough. So we have to add a lot more events, meaningful events, and also the events can occur before or after certain event. So you cannot just use a fractions to describe those events. So that's the limitation of the P system. And then typically in biomechanical research, we're using more meaningful names than the P numbers. Now, let me give you some additional examples where we used those additional events that I introduced earlier. So for example, in kinematic sequence here, actually in golf swing, there are three kinematic sequences, the backswing sequence, the transition sequence, and the downswing sequence. But in this case, I will just focus on the transition sequence. So the transition point means when the body part changes the direction of rotation. And typically, it will be a pelvis to club, central to a peripheral sequence. But here we have the angular velocity patterns of all the body parts. The red line is the hip line or the pelvis. And then the green is the shoulder line. And the blue is the upper lever. Basically, this shows the motion of the arms, roughly. And then the pink line is the club. And then this sky blue line is the wrist angular velocity. So it shows the wrist motion. And on the right side here, I have the angular positions observed on the swing plane. Also, in the next episode, I will introduce the concept of functional swing plane. But when we look at the rotational motion of the body on the functional swing plane, then you'll be able to calculate the angular positions of the body parts. So again, this is the pelvis or the hip line. And then the green is the shoulder line. And then blue is the arms. And then the pink is the club. And then this sky blue line, this shows the wrist cock angle. So when the hip line angle shows this maximum value here, the most rotated position here, that's at this point here. So in the angular velocity pattern, the curve crosses the horizontal axis here. And then at this point, the angular velocity is 0. That means the angular velocity stops increasing and then starts decreasing in magnitude. So this point is the EPR, end of pelvis rotation. And then the next point is the ESR, end of shoulder rotation, and the end of arm rotation. And then this is the top of action here. So these events are important in terms of assessing the transition sequence. And then from EPR to top of action, this phase is defined as a transition phase. So by finding these timings, you'll be able to clearly see whether the golfer has the expected central to peripheral transition sequence or not. And also, if you look at the wrist angular velocity or wrist cock angle here, this is when the wrist shows the most cocking here. So this is maximum cocking, or this is the beginning of the uncocking phase, and then which is this point here. So this is the release point, or the beginning of the uncocking, and or I call it the maximum cocking here. So these events are all basically detected based on these graphs here. So these events are not based on the club positions, but rather these are based on the body rotations here. Another example is based on the ground rotation force pattern here. And then the green line is the ground rotation force acting on the lead foot. This is the vertical component only. FZ stands for the vertical ground rotation force. And then this blue line is the force acting on the trade foot. Then as you can see here, the force is acting on the lead foot and trade foot change throughout the swing. And then the red line is the combined vertical ground rotation force. And you can see here, here's a good push during the backswing. And then this is the unweighting phase. When the vertical ground rotation force is less than the body weight, then it's called unweighting. And this golfer shows a continuous unweighting at the end of the backswing. And then slightly early part of the downswing here. So he has continuous unweighting all the way. So this is the maximum unweighting event when the ground rotation force becomes the smallest. So this is the maximum unweighting. And then obviously this will be the maximum GRF, maximum ground rotation force here. So we can detect these events based on the ground rotation force curve. And this one shows the maximum hand velocity event here. So this is the hand pad. And then this is the swing plane view. So when the hand moves along this path during the downswing, at this point, the hand reaches the peak velocity. And then once you pass this point, then the hand will start slowing down. While the hand is slowing down, the club will keep accelerating. So that's what happens in the downswing. Again, we can certainly detect all these meaningful events in addition to the typical P positions. So these are the examples of the additional events that we use. And then based on the events, now we can define the swing phases. And so here's the breakaway, top of action, ball impact, and the late follow through. From, in my classification, from the breakaway to a top of action, this is defined as the backswing. And the top of action to impact is a downswing. And the impact to a late follow through is just a follow through. And then you also have a P10 position, which is probably when the club is aligned horizontal. But usually I just stop looking at the swing, typically at the late follow through here, which is P9 position. So based on these, simply I can divide the whole swing into these phases: backswing, downswing, and follow through. But in the analysis, I can use a slightly different approach. So for example, by adding mid follow through here, when the club is parallel to the ground, then starting from top of backswing to a mid follow through can be defined as extended downswing. So in this perspective, basically the motion between impact and mid follow through is a continuation of the motion from the previous stage. So you cannot really separate this from the previous motion. So that's why I go from top of upstream to lead follow through and use this as the extended downstream phase. And then between EPR, end of pelvis rotation, and the top of action, this is the transition phase. This is my definition. In the transition phase, obviously, we expect a good central to peripheral transition sequence. So the body parts will start rotating in the opposite direction at different time points. But more importantly, during this transition phase, your lower body keeps interacting with the ground, and actually, you can generate a good amount of torque during this transition phase. So the transition phase is more than just a sequential transition from the pelvis to the club. But rather, it also means golfer club interaction, a lot about the golfer club golfer ground interaction. And the reason why I emphasize the importance of a mature transition or elongated transition is because during this phase, you are working with the ground quite a bit. And then if you use the ground well, then when you start the downswing at top of upswing, you'll already be able to generate a large amount of torque so that you can have a good initial condition to start the downswing with. So this is the transition phase. And then from top of upswing to early downswing arm-based, when the lead arm is parallel to the ground here. But this phase is defined as early downswing in my case. And then EDA to impact is a late downswing. When I classify the downswing phase into early downswing, late downswing, this is based on the torque, the frontal plane torque. So generally, around the EDA, on the average, around the EDA, the torque becomes a maximum. The golfer generates torque using the ground, but the torque becomes a maximum around EDA on the average. So from here to here, the torque increases, and then from EDA to impact, the torque decreases. So I divide it into an early downswing phase and late downswing phase. But at the same time, by using early downswing, where the club is aligned vertically, so from TV to ED, I can call this the acceleration phase, the ED to be impact as a deceleration phase. So this is based on the rotational acceleration of the body. So around the ED, all the trunk segments and the shoulder girdles and the arms reach their peak angular velocities. So from here to here, you have angular acceleration. And then from ED to impact, you have angular deceleration of the body, while the club keeps accelerating. So based on the angular acceleration or deceleration, we can call this phase as the acceleration phase, and then this phase as the deceleration phase. So by focusing on the mechanical phenomena happening during the swing, we can further classify divide the swing phases into meaningful phases. So these all will enrich the golf swing analysis. So that's why I try to introduce the swing events and phases here. And so from now on, when we talk about other concepts, I will use these events, and you will be able to refer to this particular episode to look at the meanings of these different acronyms here. Okay, so in this episode, I focused on the important instance of the swing, the so-called swing events, and then also all the phases defined based on the swing events. Thank you very much.